Okay, next up is 9.3, which is geometric sequences and series. And if you remember from 9.2, arithmetic sequences and series, that meant that we added or subtracted the same amount from one term to the next. Geometric means that you are either going to be multiplying or dividing by the same thing each time. So the value, being multiplied or divided is the common ratio r. And to find the value of that common ratio r, all we do is we divide one term by the term previous to it. So if we're looking at this sequence right here, and we want to know what is the common ratio, we'd just pick any two terms. I'm going to pick these two. And we divide a term by the term previous to it, which means I'm going to divide, 50 divided by 100, and 50 divided by 100 is a half, or 0.5. I could also have chose these two terms right next to each other and did 25 divided by 50, and I would get 1/2. I also could have done those two and said 12.5 divided by 25, which also would be 1/2. So the common ratio in this particular example is 1/2. So as I look at my next one here, I'm going to look at, let's do a different color here, at this sequence right here. And this time, I'm going to pick any two terms. If I pick my first two here, one term divided by the term previous to it, 5/2, which is also 2.5. I could have picked these two terms. Oops, I missed a, oops. That should have been, there's decimals in there. So if I did 31.25 over 12.5, if I did that, 12.5, I would also get 2.5 when I divided those two out. Again, I could have picked any two terms and just divided one term by the term previous to it. So in this case, the common ratio of this particular sequence is 2.5, which means going from one to the next, it's multiplied by 2.5. Okay, again, as we move along here, we are going to have some more formulas that we're going to need to know, okay? So this is how you, kind of like we had the arithmetic yesterday. So remember, just a reminder, arithmetic rule that we were learned yesterday, that our formula was a sub n equals a sub 1 plus n minus 1 times d. Again, a sub 1 is your first term, d is your common difference. This time, we are going to use one for a geometric sequence. And here we have a sub n equals a sub 1. And we do need to probably be a little bit careful here so that we know what's being multiplied together. I like to put parentheses around my common ratio, just so I know that the ratio, the r, is what is being raised to that power. Okay, so if I wanted to write the first 5 terms of a geometric sequence whose first term is 3 and a common ratio of 2. So that means my first term is 3 and my common ratio is 2. That means I'm going times 2. 3 times 2 is 6 times 2. 6 times 2 is 12 times 2 is 24 times 2 is 48 times 2 is 96. Have I got there yet? How many did it ask for? The first 5 terms. There we go. So I actually went 6 there. So the first 5 terms of the geometric sequence would be 3, 6, 12, 24, 48, 96. If I wanted to write a rule for that, right? So here's my terms in my sequence. If I wanted to write the rule for that, I would have a sub n equals my first term, a sub 1, which is 3, times r, which is 2 to the n minus 1. And that would allow me, if I wanted to know, for instance, what is the 10th term in the sequence or 9th term in the sequence, anything like that, I could just put that value in for n. Okay, so that's what it looks like. That's what we're going to do here next. What is the 15th term of the geometric sequence whose first term is 20? So that means that we have our first term, a sub 1 is 20, My common ratio is 1.05, so we're going to use that formula a sub n equals a sub 1 times r to the n minus 1, which would give us 20 times our ratio 1.05. And we are trying to find the 15th term, so it's actually going to be a sub 15, to the 15 minus 1. Now, when we go to put this in our calculator, we need to be very careful because we do not multiply 20 times 1.05. We need to make sure that we are using parentheses appropriately, so you'd want to make sure in your calculator you'd have 20 and use those parentheses to say 1.05 to the 14th. This tells the calculator the only thing being raised to the 14th power is the 1.05, and it will do the order of operations correctly. So if we go ahead and put that in our calculator, we would end up at a really long decimal where our 15th term is 39.5986, blah, 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 and we're just going to round that to 39.6. Okay, let's just look at another one. This one might be a little bit easier, not so many decimals. The 12th term of the following sequence, so we're looking for when n equals 12. Our first term is 5, and our common ratio looks like we're multiplying by 3 each time. So if we want to find our 12th term, we are going to take our first term times our ratio to the n minus 1, which is 12 minus 1. And we put that in our calculator very carefully with making sure we're using our parentheses correctly. We would end up at 885,735. So that 12th term, when we're talking geometric sequences, gets very large very quickly when you have a bigger ratio. Oh, and hey, look at that. Guess what? It's another formula. Okay, so if we want to find the sum of a finite sequence, that means it has a starting and an ending point. It does not have an infinity. This is the formula that you need to use. Okay, so we're focusing in here. So this is what's going to be given to you, and then you're going to have to use that information in order to find your sum. So if you notice, this is the problem given. It looks very similar. Looks like that. So we just have to pick out our pieces of information. Okay, so using our formula up there, I know that 12 is my value of n. That's where I'm stopping at. This number in front right here, that's my a sub 1. That's my first term. And then this, what's in our parentheses being raised to the power, is our common ratio. And if you use your formula, those are the only 3 things that you need. So you'd have your s sub 12 in this case, because we're going to the 12th term, is going to be your first term. So we're going to have this formula right up here. We're going to use this formula right up here, a sub 1, parentheses, and we're going to be very careful when we write it and when we put it in our calculator to make sure that we are putting it in there correctly. So our first term was 4. And then inside of our parentheses, we're going to have our fraction bar. On top, we're going to have 1 minus r, which is 0.3 to the n, and n is 12. And then in the bottom, we have 1 minus 0.3. Make sure you're using your parentheses carefully. When you put that into your calculator, use your fraction button, all that kind of stuff. And if you do it correctly, you should end up that the sum of the first 12 terms of that sequence would be 5.714. Okay. Yesterday we did where, if you remember, yesterday we wrote it all out where we said 4 times 0.3 to the 1 minus 1, 4 times 0.3 to the 2 minus 1, and we just kept adding them up individually. This allows you to actually find a sum without having to write every single term out that you're adding. Okay, so this one is interesting because we have to be a little careful, right? So this is our n value because that's where we're stopping. This 2 right here, okay, is being raised to the power. Whatever is being raised to that power is your value of r. Well, if we have an n and r, there's nothing out in front there, which means what's our a sub 1? We need to know what number is out in front. And if we think logically about this, right, what number is out in front of anything if there's nothing there? What's it being multiplied by? So in this case, our a sub 1, oops daisies, our a sub 1 is going to be 1, because if there's no coefficient out in front, that means there is a 1. Okay, so then we're going to go back. Let's look up there at that formula that's in green, and we'd have a sub 1 is 1. In our parentheses, 1 minus r is 2, and our n value is 7 over 1 minus 2. Again, very careful when you put that into your calculator, and you should end up at your sum of the first 7 terms is 127. Okay, well, the last slide talked about the sum of a finite geometric series. This is when you find the sum of an infinite geometric series. And if you think about it, you think about adding something that goes to infinity, it seems like that's not something that you should be able to do, because it seems like your number would go on forever. So we have this rule right here that our common ratio has to be between 0 and 1. Okay, and if you think about why that must be true, let's think logically about it, right? So if, let's say r is greater than 1. Let's say r equals 4. No, let's do something simpler so I can do it easier. R equals 2, okay? That's greater than 1. If we put a sequence out there that was like 2, our ratio is 2, so that'd be 2 times 2 is 4. 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and so on. If you kept adding that, that would get larger and larger and larger and larger, and you never end up with a number, okay? However, if our ratio is between 0 and 1, okay, like say r equals a half, okay, if we started at, let's say 8, okay, we'll make a small starting point, and we added half that would be, we'd add 4, then we'd add 2, then we'd add a half, then we'd add a fourth, then we'd add an eighth, then we'd add a 16th, and this number that you're adding keeps getting smaller and smaller and smaller, which means eventually you would just be adding essentially 0 onto it. So as long as r is between 0 and 1, we are actually able to find a sum. However, if your r, your value of your common ratio, is greater than 1, then it's not possible, and we would use d-any. So if r is greater than 1, we would use does not exist. Okay, so if we wanted to find our sum, oh, actually we should come back up here real quick. So our formula that we need to know, again, this is our rule that we're going to use. And if you notice, that looks very similar to what we have here. Okay, excuse me, which means that we know our rule, and we're going to find our s sub n. We're going to go to infinity here. So we're going to have a sub 1 over 1 minus r. That's the formula that we are going to use, and it's another one that you need to know. And it's really simple to use, because if you look, a sub 1, right here, let's label our stuff here, looking at our rule. This is our a sub 1, and this is our value of r. And those are the only two things you need to know to find the sum. And if you notice, your ratio is less than 1. Okay, so that's good. So we know that our ratio is less than 1, which means we know there is a sum. So then we can say our first term over 1 minus r, which is 0.6. And if we put that into our calculator, again, being careful to make sure that we are using the fraction button or using parentheses appropriately, we should get that our sum is 10. Okay, let's look at one more example here. Actually, I've got 2 more examples. So we've got our rule here. Our 5 out in front is our first term. That's our a sub 1. 1/2 is our common ratio. And again, those are the only 2 things we know. So our sum as we go to infinity is going to be our first term over 1 minus our ratio. And when we put that into our calculator, we can go like this and say our sum as we go to approach infinity is going to be 5 divided by a half, which is also 10. Example 3 here, okay, is a little bit tricky because if you just look at it and you say, oh, here's my a sub 1 and here is my r, okay, we should notice something, right? We should notice that our r is greater than 1 and say, uh-oh, not good. Okay, we can't do that, which if we come across one where our ratio is greater than 1, that means we don't have a sum and we can just put does not exist. Okay? All right, last thing, of course, is applications and story problems, which is everybody's favorite. But when we start talking here in question number 1 about buying a brand new Ford Bronco, it is worth my time. So assume that a new vehicle loses 12% of its value every year. A brand new top-of-the-line 2022 Ford Bronco retails for $82,000. How much will the Bronco be worth after 5 years? Okay, so a couple of key things here. We know that our Bronco is losing 12%, which is 0.12. That's how much it's losing. However, if it's losing that much each year, it is still remaining at 0.88, the value that still remains every year. Okay, so when we go to do this, our rate is not going to be 0.12. Our rate in this case is going to be 0.88. Okay, so let's think about that for a minute here. So we're going to use our formula, a sub n equals a sub 1 times r. And the other thing we need to look at is the question, the way that it is worded. Okay, it says how much will the Bronco be worth after 5 years? So that means it is the end of the 5th year. So that means we are not going to use n minus 1. We are just going to use n. Okay, if it was the beginning of the year, then we would use n minus 1. But since we're including that entire 5th year, then we are going to use n, not n minus 1. Okay, so what I want to know is how much it's worth after 5 years. Well, I know it starts at $82,000. My rate, again, is how much is left that it is worth, not how much it went down, but how much it is still worth, which means 0.88. And again, we are using n, not n minus 1, because we are calculating it through the entire year. Excuse me. So again, using our calculator, being careful to make sure that we are not doing anything with our parentheses that would make our calculator do anything incorrectly, we should get that the Bronco, after 5 years, is worth approximately $43,274.02. So in 5 years, it almost worth half of what it was when you first bought it. Okay, and then this is just a good question because we haven't done logarithms in a while. How many years will pass until the car is worth $30,000? So if I know my car is worth $30,000, we're still just going to use that formula, and we're going to use our first, which was 82,000. Our rate is still 0.88, but we don't know how many years that's going to be. So now we're going to have to dig deep down into our logarithms knowledge. And remember that if we have this variable is in the exponent, we have to rewrite it as a log. So the first thing we need to do is we need to divide both sides by 82,000. And when we divide that, we get 0.3659 equals 0.88 to the n. Okay. Now coming up over here, how do I get that variable out of the exponent? I rewrite it as a log. So I'm going to have log. Remember, my base is 0.88 of what I'm taking my log of, which is going to be 0.3659 equals n. And again, you can calculate that in your calculator. That remember under the math button, if you arrow down, there's the log base. You can find any log base that you want, and you should find that your n equals 7.86, which means it's approximately 8 years. It'll take 8 years for it to be worth $30,000. Okay, so then the second one, same basic idea. So actually, I think what I would like for you to do is just pause the video, okay? Read through the question, follow the example above, and see what you can figure out for how much the value of the machine will be after 8 years, and then how long it'll take until the machine is worth $10,000. Okay, so go ahead, and if you took a minute to actually finish that one, you should find that after 8 years, the machine was worth only $17,000. Yikes, that loses a lot of money in a hurry. It was worth $17,519.76. Just making sure you remembered that if it depreciates at 25% per year, it maintains 75% of its value. So we're using 75% there, not 25%. And we can use our calculator to figure out how much it's worth. And then down here in the bottom, I started out with my equation. Here, I divided out $175,000 on both sides to get my decimal. I rewrote it as a log and ended up at 9.95, which is approximately 10 years.